Welcome to NaniCodes placement ready series. Today's daily Leetcode challenge question is out of boundary paths. Let's discuss the question briefly. There is a M cross N grid with a ball. The ball is initially at the position start row, start column. Start row and start column is given itself in the question, which represents the starting point of ball in a grid. Start row is index value of row. Start column is index value of column. From where the ball is starting, you are allowed to move the ball to one of the four adjacent cells in the grid. You can apply at most max move moves to the ball. That means you can apply only the two moves. Here max move is represented by, here max move is given as 2 in this example. So we can apply only two moves for this example. It will be given for every example. So given the five integers m, n, maximum, start row, start column, these all are given itself in the question. Return the number of paths to move the ball out of the grid boundary. So we need to move the ball out of the grid. So we can move in these types of various ways represented here. So since the answer can be very large, we use 10 power 9 plus 1. We will use a modulo operator here when the answer is very large. Okay, let us understand the code by using this example. As mentioned in the question, we should throw the ball out of the grid by using maximum two moves. So it's given two moves. You can use a single move and also a double move. So if n equal to 1, we can throw using these two types, two ways. These are the two ways. Throwing the ball out of the out of the grid with one move, and these four are the two moves, and these four are using two moves to throw the ball out of the grid. So if the ball is placed at particular index, it can be moved off the field in total 6 ways. 1, 2, 3, 4, 5, 6 ways. So there are also three moves, but we take only two moves. So three moves are neglected. So let's make a table here. Let's make a table. Sorry. Okay. Here we are at position x in the row and position y in the column, and we need to throw out the ball using n moves. X represents the row index and y represents the column index, and n will be the number of moves needed to throw the ball out of the grid. So in this question they are given that ball can be moved in four directions: first direction, second direction, third direction, and fourth direction. So the ball can be moved out of four directions. We need to start from x and y index and move the ball from n moves. So if we take all the four directions of position as n minus 1, so from here it is n moves, from here it will be n minus 1 moves, and from here it will also be n minus 1, here also be n minus 1, it's also n minus 1, it is also n minus 1. So all the four directions are updated with n minus 1 values. If we count to calculate, okay, all the moves are represented with n minus 1. If we want to calculate values of n minus 1, we need values of n minus 2. So if we need values of n minus 1, so let's choose this. If we are at here, if we want to calculate the values of n minus 1, we need to calculate the values of n minus 2. This also n minus 2, and this one also is updated now with n minus 2. If you want to calculate the value of n minus 1, we need to calculate the values of n minus 2. Here we are using its pre-calculated values for the lower number of maximum values allowed for computing values of current node. So if we have the values around its boundaries, we are not able to if we have the values around its boundaries, we will be able to find the answer. So uh, if we are at the boundary, then we can find the answer, and we will update to n minus 1 moves, and from n minus 1 moves we will get n minus 2. Like that, it's a recursive calls. If you want if you want to find the successful answer, then uh, Hmm, we'll find the successful answer when the ball goes out of the boundary. That is, if I turns if I turns to be lower than 0, that means here I equal to 0. Actually, here I equal to 0. Actually, if I turns less than 0, it's one case, and if j turns less than 0 is also one case. If I will be greater, if j I and j are greater than I or j, I or j greater than n or equal to n is one more case. Greater than or equal to n is one more case. So we have four conditions to get the value successfully: I less than 0, I less than 0, I j less than 0, I less than 0, j less than 0, and I comma j are greater than or equal to n. So uh, let's start coding. Let's understand the code by using this algorithm. So first we need to declare a 3D array. It will be of type long, and it is initialized to value null. And we need to declare one mod variable here with values of 10 power 7 plus 7. I think, let's see what's the value. 10 power 9, sorry, 10 power 9 plus 7. We need to initialize it with 10 power 9 plus 7. This is a 10 power 9 plus 7 value, and now we take the memo, and we take the memo with boundaries m plus 1 and n plus 1 and maximum plus 1. Now I have used helper function here which helper function here which performs DFS approach and using memorization technique internally. And here Here, if the function moves less than 0, we need to return 0 first, and it's a boundary condition here. Now, if rows or columns are out of boundary, we need to return 1 directly, and if then we need to then we need to check memorization array. Then we need to check the memorization array if I have ever pre-calculated this value in the past or not. We'll check here. Just need to check whether we have calculated this value uh, in we have calculated this value previously. So if I done that, current max allowed, I return that. Otherwise I go and take value. If I done that, current max move allowed, I return that. Otherwise I go and take a value which is 0. Otherwise I have to go and take the value which is 0 here. And these are four statements represent the traversing and uh, calling all the paths from the current position, from maximum minus 1, from row comma column minus 1, from row comma column plus 1, row minus 1 comma column, row plus 1 comma column, all the four directions where the from I comma j. Now add all these to total and perform modulo function here. Now add all this to the total and perform mod function here. Now store this in a DP array and return the total. Let's run the code. Accepted successfully. For test cases also it would run successfully. We will submit 100%. Okay, thank you.